All right, let me share my screen and let's do the quiz together. Okay, so here's our quiz. And question number 1 is, suppose you wanted to conduct a study of the proportion of registered voters in California who regularly wear a mask when they're in public, even when they are not required to wear one. You will use a sample size of 600. Explain in detail how you would identify the 600 registered voters using sample techniques. So there's a lot to do here. So let's start out with stratified sampling. So what does stratified sampling entail? What do you have to first do? If you remember, there was a step-by-step process for stratified sampling. What was the first step?
Determine the strata, like split it up into a smaller group.
Good, good. And now the question is, what do you think might be a good strata for this particular study?
Political affiliation.
Okay, that might work. Political affiliation would be a good one because my guess, again, I have not done the statistics, but from the I've heard is that Republicans and Democrats treat this differently. And again, I have not done the personal study, but I have heard about that. So first, look at, or first determine the strata and let's use political affiliation. And one also really nice thing about political affiliation, if you read the question, what's our population?
Registered voters.
Registered voters. And that means, I'm not sure if you realize it, but when you go to the county clerk's office, they will tell you what the person's registered as. Okay. I don't know if you realize, but that's actually not private information. Actually get a list of all the registered voters. Okay. And I don't know if you remember, do you know why I know about these things?
You worked with the Democratic Party with somewhere, I believe.
I did that, but even more important, I was a politician for 9 years.
Oh, that's right.
So I had to run for office and all that kind of stuff. So I definitely know about this. You don't have to know about it. You could have chosen, I'm good with it. If you chose ethnicity, I'm good with that too. But you got to choose something. Does that make sense? And so I went with the first one that somebody said. That's all I care about. So let's use political affiliation. Next, what's the next step?
Research the percent of each group.
Yeah. So next, research the percent of, I'm going to just say Democrats, Republicans, and let's just call it other. Okay. If you want to add some more, you can add some more, but it's a quiz. There's no reason to type forever. So Democrats, Republicans, and others pretty much do it. Who are registered in California? Do you think that's something you can find out about? What do you think?
Yes.
Yeah, I'd say less than a minute. Just type in, what's the percentage of Democrats in California? And it'll tell you immediately in Google or whatever you're using. Okay, any questions on the next step, on that step? Okay, what's the next one?
Multiply the percentages by the sample size.
And what is that in this case?
It would be the number of...
Looking for a number.
600.
600 is given. Okay, this is the one part, you're not actually going to do the math, but you're going to describe the math. Then multiply each of these percents to establish quotas. Any questions on that? And then finally, survey that many people of each. Any questions on stratified sampling? Okay, note that had you chosen something other than political affiliation, that's fine as long as you understand the steps. Okay, so I'll be reading it, and the key is explain yourself. Okay, now we go to cluster sampling. All right, so cluster sample, what does that involve? What do we first have to do?
Determine your clusters.
We have to divide the population into clusters, a lot of clusters, so that each cluster is a reasonable number. Remember, we're only surveying 600 people. So you might have a cluster of 50 people each cluster or so, not a lot. So where might you choose clusters in this case? This is California.
North and south.
And do you think you could survey every person in Northern California?
No.
Then that won't work. How about counties? Could you survey every person in Los Angeles County? No. Again, too many. You need clusters where you have a reasonable number that you can actually survey all of them in each cluster. Any other thoughts? And there are different examples. So think small. Okay, maybe I'll suggest. How about streets? Right? You could look at what street everyone lives on. Okay, and again, that's not the only possible cluster, but at least on any given street, or maybe block is probably better, street blocks. So use street blocks. There might be a better word for that, but I'm going to use it. Okay, so everyone, pretty much most people live on some block, right? Okay, so use street blocks and clusters. Okay, and if you don't like street blocks, you could use acres, for example. And then those would be clusters. Does that make sense? Okay, then what do we do? Any ideas? I don't see y'all jumping in. So you're doing cluster sampling. Once you've decided what all the different clusters are, then you select clusters, certain clusters within that set to survey. Then select several representative street blocks such that there are a total of 600 residents or registered voters that are selected. So again, we're talking about blocks, so you might want to choose, for example, make sure you select blocks in the city, maybe the suburbs, and maybe one rural. Because most people in California don't live in rural areas, but that's why you do like one representative rural area, more than cities and suburbs. Any questions on that? And then what's the final thing? What's the last thing to do? It's actually the hardest part in the real world.
Getting people to actually answer the survey.
Yeah, and not only getting the chosen people, then survey all of the 600 chosen people. Okay, and that might be hard. Again, paying money works. tends to work. Most people are good with getting money and they'll do a survey. Any questions on that? Okay, random sampling. That's actually the easiest one to describe. How do you random sample? That's really the only way that I told you.
You could use a computer to select 600 registered voters from California.
Yep. So get a list from the state. And by the way, you are able to get that. Okay. Again, I don't expect you to like know all these rules, but that actually is something that is available. Get a list from the state of all registered voters. Order them. And probably the easiest would be alphabetically. Again, doesn't matter how you order them, but alphabetical with computers, that's easy. You just go to Excel and hit alphabetical. And have the computer select 600 of these voters. Then survey them. Any questions on random sampling? I do want to give you a big warning. It's the easiest one to describe and the hardest one to do. Random sampling is really hard in terms of the real world. It's easy. Convenience sampling is actually pretty easy too. What about convenience sampling?
Survey people from your town.
Yeah, just survey the closest and easiest to find people, or actually registered voters, that you can find. Okay, convenience sampling and huge bias, but it is what it is, and that's how you do it. Any questions on question 1? Question?
Yeah. Do they have to be, so you said, and because I kind of ran out of time, like in the quiz. I think it's because I was, thinking about it too much, and I was like doing like complete sentences for each, like more like small paragraphs. So I don't know. Do they have to be like, how long would you advise them to be?
Okay, so the first thing, and don't tell other teachers this, but this is not an English class. So I'd never grade you on your English. Does that make sense?
Yeah.
All that matters is you express your ideas, and the ideas need to be what these things are. Does that make sense?
Yes.
And whether you use complete sentences, I don't care. If you use bullets, I'm fine with that. If you spelled them all wrong, as long as I can read it, I'm okay with that. So don't spend any time doing that kind of stuff. For your projects, though, because that you have weeks to do, you're working with partners, you should be looking at each other's papers and fixing it. That one you should actually have written nicely. Does that make sense?
Yes.
But for the quizzes, no, these are timed, and I definitely would never grade you on things like, how beautiful your style is. That's not something you should ever worry about for a quiz, because what you need to worry about is that you have really written about the main points of each of the sampling techniques. So I went through and I gave a step-by-step stratified sampling list on Tuesday. Hopefully you remember that. So I was looking for that list to be addressed.
Okay. And
similar with cluster sampling, I was looking for the method of cluster sampling to be addressed. Do you see that?
So the definition, in other words.
Yeah, but don't just write the definition. It needs to be about the 600 registered voters. Does that make sense?
Yeah.
If all you do is copy and paste the definition, that's not good enough.
Okay.
You need to actually write about the question that's asked. And that is these registered voters, and there's 600 of them. Does that make sense?
Yes.
Yeah, so not just definition, but how you apply the language to the question. Does that make sense?
Yes.
Yeah, but don't spend time trying to make it beautiful because that's not important. Okay, project on the hand, make that beautiful. Let's go to question 2. Question 2 is shorter, by the way. So suppose you're interested in better understanding how people's grocery shopping habits have changed from before the pandemic. Come up with a survey question such that the variable is, so 2 questions. First, quantitative. Who can come up with a survey question so the variable is quantitative? It's really easy. There's a lot of different questions you could ask.
What % of Americans were looking for toilet paper between the month of March and June?
Okay, but you're doing a survey question. You're asking, let's say you're asking 500 people. What are you going to ask the first person? And the second, you're going to ask everyone the same question. You're not going to ask them what percentage of Americans. Does that make sense?
Yeah.
So that wouldn't be quantitative. In fact, that would be a qualitative study.
Okay.
Because the question on that would be a yes or no question.
How many times was your grocery store out of an item that you needed
That works.
in the past year?
How many times was your grocery store out of an item that you needed in the past year? Okay, so there's a survey question. So it's not that what is a study about, but what is a survey question? What are you going to ask each of these people? Does that make sense? And notice, I asked you, how many times was your grocery store out of an item that you needed in the past year? Tell me the answer to you, for you personally. You can put it in the chat box or say it, you choose, all of you. Okay, so notice, what are we seeing as the answers? Okay, everyone answered with a number. Do you see that? That's what matters, is you look at the survey question and you see a number for the survey question's answer. Does that make sense? And that's what quantitative is about. Now let's do qualitative. So what would be a qualitative survey question that would help better understand people's grocery shopping habits?
Maybe like what products have been in shortage this past year?
Okay. How about you seen? Having a shortage in last year. Okay. And one obvious one would be toilet paper, right? Okay. The answer would not be 8. It would be toilet paper or maybe flour. Okay. All kinds of different things, words. And that's the main thing, is that the answer to the qualitative survey question needs to be a word. Any questions on the quiz? Any questions? Look at that. I actually finished it in less than 20 minutes. And that's with all the explanations and stuff. So I don't feel too guilty because it wasn't too long. Any questions at all on how this quiz works? Okay, I want to let you know this is kind of a, how the quizzes are going to be. You're going to be writing a lot or typing a lot. Be ready for that. These are not multiple choice. These are not, because that you get on the assignments, the homework, the regular chapter assignments. I don't need to give you multiple choice questions because you already get that. Or what number do you get? I'm going to have you do this. So are they graded in accuracy? Yeah, I mean, accuracy is kind of a vague word. So I'm going to look at it. And for example, if you switch these two, that's not good. So quantitative needs to be a survey question with a number answer, whereas qualitative needs to be a survey question with a word answer. Okay. And again, there's there's an unlimited amount of correct answers, but there's also an unlimited amount of incorrect answers. So that's what I'll be looking at. You know, I'll be saying, did you ask a question? And was the answer to that question for the quantitative one number? And for a qualitative, what would the answer be in words? Okay, and similarly, I'm going to look at, did you get at the main point for the different sampling? Did you really talk about stratified with the steps? Did you find your clusters and talk about choosing enough clusters of people? Right? Did you somehow get a list and then use the computer to grab numbers from the list? That's going to be random sampling. Okay, and then convenience is, did you just make it easy for yourself? So that's what I'm going to be looking at, if that answers your question. So I can read this and see whether you got it or not, or that you just don't really understand what it is. Okay, whereas a computer can't do that, by the way. Okay, at least not yet. Ask this question on a computer, it can't grade this. So at least now I'm still smarter than some computers, that you are too. We'll see in 50 years, but. Okay, I think I want to go to chapter 2, because that's what today is about. Now that we have our quiz finished, and I want to let you know this is pretty standard. This is pretty standard for how the class is going to work. Hopefully, it's okay with you guys. That'll always start with 5 minutes of introduction. Then we'll do a 20-minute quiz, and then we'll get back to the content that we have for the day. So hopefully that works for you. You know, if you have suggestions, I'm happy to listen. So what we need to talk about now is statistics. I know that's what the course is called, but that's what we're going to do. And there's a whole lot of statistics to talk about. And really, I don't think it helps much at all for me to sit there and give you a formal definition of each of these statistics. I think the best way of learning is by example. So what I thought I'd do is at least do one statistics by example, and then talk about some of the others too as we go. So I like, and this is something you're going to get from me, whether you like it or not, I always like with something that is current. And what I've got is California housing market report. Okay, because you might be interested in that, you might not. And so we want to say, well, what is a good statistic to understand how expensive houses are in California? Do you think the average house price is the best statistic? What do you think?
No.
Why not? Why not? What's wrong with the average?
It'll be probably be really large because of the really expensive houses.
Yeah, so if you're interested, so the answer is, this is a trick question. And I do that a lot. I don't give trick questions like that kind of complete trick questions on a test, but I will in my lectures. So the answer is, it depends. Isn't that a tough one? So if you're thinking about moving into a community and getting an idea about what the community's like, the mean does not work. And let me give you my community as an example, and some of you also. I don't know how many of you are in Tahoe, but if you live in Tahoe, I'm not sure if you know, but do you realize that Tahoe often has the most expensive house in all of America? Isn't that scary? Do you think I live in that one? Any guesses?
No.
No, I'm a teacher. I don't live in the most expensive houses. Okay. I know one of the most expensive was bought somewhat recently. Okay, a year ago. And have you heard of Facebook?
Yeah.
So do you know who's started Facebook?
Mark Zuckerberg.
And he bought a house in Tahoe. I don't know if you know that, but he did. Okay. And do you think he paid the same as what I paid for my house?
No.
Oh, of course not. No, he paid, I think, something like $30 million, some obnoxious amount of money. At least obnoxious to me because I can't even imagine that. And the problem is if you look at the average home price, then when you take an average, then that one house that's $30 million is going to skew that average way up high. And in fact, if you look at the average home price in say, Tahoe or California, there's very few that are anywhere near that average, because you got the super rich one and you got the middle ones. Okay. And by the way, same idea. If you're, let's say you're looking at salaries in a company, do you think the average salary is a good idea to look at if you want to say, what do people make in this company? What do you think?
Probably the median, because like the CEO is making so much more than like the
Exactly. So same issue with salary is that if you look at the average salary, then nobody's making the average salary in most small companies. It just doesn't happen because that one, the CEO usually makes the millions and everyone else makes, you know, a little over minimum wage or something. And then the average.
I love capitalism.
Yeah, again, I'm not telling you whether it's good or bad. I don't go there. That's not my job. But I will tell you that average, if you want to look at kind of what a typical person makes at that company, looking at the average is worthless. Does that make sense? Because nobody makes that amount of money. So instead, for housing prices or salaries, if you want to look at the kind of the typical person or the typical house, the median's better. So remember, the average is you add them up and divide by the total. Who remembers what the median is? So let me scroll down. You can actually see the median prices in all kinds of places. There's a nice, that's why I like this article, because it gave a chart. And you can look at the median house prices. So for example, San Francisco is very scary, by the way, in terms of median. Yeah, the median price is the middle price, okay? So you order all the prices in order from lowest to highest and take that middle number. And technically, if there's an even number of numbers, you take the average of the two middles. So look at San Francisco. Okay, and the first column tells you the newest. And notice that, that the median San Francisco homeowner is a millionaire by definition if they own their house. Okay, because they have a house that's worth more than $1 million. Pretty scary, isn't it? Okay, and by the way, a year ago it was a lot less. So you'll notice that prices of homes, the median price of homes, have gone way up in those 12 months. Any questions on that yet? Okay, on the other hand, if you look at, let's say the Central Valley, very different for the median price. So if you think about kind of the typical person in the Central Valley who owns a home, they don't have to pay that much money compared to San Francisco. Any questions on that idea of kind of what the median tells you? All right, what about the mean? So I'm going to tell you, so now let's go to Tahoe, because that's where I live. That's where my house is. So now I have to go to South Tahoe now, and I found an article on housing prices. And we know the median purchase price is, it said somewhere, the median a year ago was $485,000. And I'm just looking, I don't know if they told us the price for this year in this article, but I'll use last year's. Okay, so we got $485,000 for the median 1 year ago. All right, so that's important if you want to say, what is a typical house like? Who is in what? At one point, I was more interested in the mean. Why might I have been more interested in the mean than the median, personally? The hint is I've already told you something about myself.
That you're a teacher?
Not from being a teacher, actually. Teachers don't care about the mean.
You were looking to buy a home?
Nope, then I care about the median because I want a normal house. What did I tell you guys that I did that probably none of you have done?
You were a
Politician?
politician.
I was a politician, okay? So when I was a politician, we needed to raise money via bond measure. Why would the mean price be more important than the median price? When you're looking at raising money from the community in a bond measure, which went on people's house, it's a house tax price.
Maybe like to see who, like how much, like if the mean is higher, then there are probably people with more money who would donate or like give money.
Yeah, it's not just that there's people, but we actually passed a bond. And like that Zuckerberg house that's $30 million, if Zuckerberg gets charged 1% of his $30 million house each year, that's $300,000. So we're bringing in $300,000 just from that one house. We do not want to ignore that house. Does that make sense? So, whereas if you're looking at a typical person, you don't care about Zuckerberg. But if you're looking to raise money using a percent of each house price, then absolutely those super, tens of $1 million houses are going to bring in a lot of cash. And when you're thinking about what percent you need to charge for your bond measure, the mean is everything and the median is useless. Anyone lost on that idea? Get the idea? So for taxes, in terms of as someone who is looking at revenue from taxes for funding schools, the median is not important, the mean is important. Any questions on that idea? Any questions? Okay, so like I said, and you're gonna get this from me whether you like it or not, I like to bring in real stuff instead of let's suppose. No, this is real. This is the median price of houses, but the mean is more important if you're looking at, say, raising taxes and getting money, you want to find out what percent of the houses you want to charge. The median is more important than the median. And the mean is more important than the median. Any questions on that idea? All right, so I want to go back to that article again. The next thing I want to say is let's look at these California. Do you think that it doesn't really matter what community you're in or what house you look in terms of house prices? Are they all basically the same house prices?
No.
They're not, okay? Are they very different or are they a little different?
Very.
They're very different, okay? So in statistics, we need to have some kind of quantification of how different numbers are. So we look at these and they're very different. We got the Bay Area's got $1 million, whereas the Central Valley 386, and then I don't know, the California condos are 515, et cetera, et cetera. They're all over the place. So there is a measure of how all over the place the numbers are. Anyone know that measure that you might have learned in high school? Especially if you went through Common Core, you probably learned about it. So if you're younger, you learned it. If you're older, you may not have. What is a measure that tells you how different all the different house prices are?
The standard deviation.
Yeah.
What is it? One more time.
The range?
Okay, the range is a good one. The only thing about the range is that then we're looking at Central Valley and San Francisco, and we're ignoring all the others.
Can't you just do the mean of it?
The mean?
Like you add them all up and then you divide it by the number of numbers.
Okay, that's just the mean.
That's just the mean.
The standard deviation?
The standard deviation. Okay, so if you can't hear anything, then it's your computer, I think. The rest of you, can you hear me?
Yes.
Yeah.
Okay.
Yes.
If you say you can't hear anything, then you might want to look at your microphone and make sure it's not, not your microphone, but your speaker, and make sure that, because everyone else is hearing, so that's not
Although
my side.
if the person says they can't hear you, then how is you?
Oh, that's a good point. Let me try.
Yeah.
I can't hear that
That's a really
explanation.
good point. There, I put in the chat box. Thanks. Yeah, I was being stupid, wasn't I? There, now they should know. They should read just wrote. Okay. So check your speaker settings if you ever can't hear. Those that you can hear me what I just said. So the problem with the range is that ignores all the different data values except the top and the bottom. The range is a nice one though. But even more important is the standard deviation. Now, some of you maybe learned about standard deviation and some of you didn't, and that's okay because you're learning about it now. What the standard deviation basically is it says, what is the mean of all of the houses? Then it's kind of an average distance from that mean. And that is basically what the standard deviation says. Any questions on that idea? Any questions? All right, so I got a trick question. Huh?
Can you repeat that?
Okay, and it's so important, let me type it. So the standard deviation is, I'm gonna write "and" because technically it's not the average. An average distance.
I don't think we can see what you're typing. If you
I have
want
to hit enter. I have to hit enter. But
Oh,
I haven't
okay.
hit enter yet. You will in a minute. So I'm saying it and then I'll hit enter and then you'll get to see it. Because I'm typing the chat and that's how chat works. Okay, it's an average distance from the data values to the mean. Now you can see it.
Thanks.
Yeah, so I have to finish my sentence before you can see it. Sorry about that. That's not true when I'm not looking at articles, but I can't type on the article so well. Okay, there are ways, but it's kind of a pain. Okay, so it's an average distance from the mean. Very important. So let me give you a somewhat trick question. Okay, let's suppose, and not just suppose, I would really see almost everyone in the class pass. Do you agree? Okay, that you'd like to see that too? I hope so. Okay, I know you maybe just care about yourself, but hopefully you care about everyone. All right, let's suppose that the average score, course score for the course was 74%. Okay, then am I satisfied? Remember, you need a 70% or higher to pass a class. So if the average score, average grade, was 74%, am I satisfied?
Yes and no.
Doesn't that depend on the standard deviation?
Exactly. So it's a trick question. Okay. Yeah, if you can hear when you use a phone, use your phone. By the way, I don't tell you what device you have to listen to. And you can also log into both if you want to. If you want the big screen and the hearing, you can put your phone on Zoom and you can also put your computer on Zoom, and that will work too. So just a note for technical things, you can do both. And you could double log in. You're allowed to do that. So the answer is, I haven't given you enough information to tell you if I'm satisfied. Is that clear? Okay, now let me change the question. I think I'll do that in writing. So suppose, because now I can type and you can see as I type. Suppose my goal is to have the average, to have most of the students pass. And that means 70% or over. Okay, so if the average score is 74%. And the standard deviation is 0.02%. Am I satisfied?
What's
Okay.
passing again?
What's that?
Oh, yeah, then you are satisfied?
So the question is, am I satisfied?
Yes.
And
Yes.
why? Why am I satisfied? Any thoughts?
Because with a standard deviation of 0.02%, the it still fits within that range. So that means that the scores would be either 0.2%, 0.02% above or below 74%, which is still within the range of passing.
Right. And in fact, I'm going to go 2 standard deviations. Turns out 2 standard deviations is even better. So I'm going to go up and down 2 standard deviations. So that means most students, so almost all the students, almost everyone, scored between 73.6% and 74.4%. So the 2 standard deviations, so farther than 2 standard deviations, is an outlier. Okay, so what I did is I doubled the standard deviation, and then I subtracted and added. So double 2.02% is 0.04%. Sorry, I need to go, sorry about that. It's 73.96 and 74.04 because I add one more decimal there. So 2 standard deviations is 0.04. If I take 74 minus 0.04, I get 73.96. If I take 74 plus 0.04, I get 74.4. Well, anything in that range is a passing score. Do you agree? Therefore, I'm satisfied. Or I have reached my goal. Any questions on this idea? Okay. By the way, if this were the case and you wanted to get a B in the class, what does this mean?
That you have a pretty decent chance of passing the class?
If you want to get a B in the class.
Oh, then you're probably an outlier?
Yeah, it means forget it. It's not going to happen. And by the way, this is not what, the standard deviation is never 0.02 in my class, but had it been, everyone got a C. Does that make sense?
Yeah.
Just about everyone's going to get a C. So forget B's and D's. This says C is the grade. Does that make sense? Any questions on that? Okay, now let's do another example. Okay, so if the average score is 74% and the standard deviation is 15%, am I satisfied? Now what can we say?
No, you wouldn't be satisfied.
No, even if we move 1 standard deviation down, we're not passing. Do you see that? Because 15% below 74% is 59%. That's an F. So since even 1 standard deviation
Can I ask, what do you mean when you say 1 standard deviation versus 2 standard deviations?
Okay, so in this case, 1 standard deviation is 15%. 2 standard deviations is 30%. because 2
Okay.
times 15 is 30.
So you just multiply the deviation number by the percentage that represents one standard deviation, or by the number that represents one standard deviation.
Yeah, yeah. So you take how many standard deviations, multiply that by the standard deviation, and that gives you how far down to go or up to go. Does that make sense?
But if you're using like more than one standard deviation, why wouldn't you just change the actual standard deviation number? Because does it always have to be measured originally within the metric of like 1?
Okay, so the standard deviation is the number that comes from the data, period. You can't change it. I mean, the only way I could change it is like give an easier test, I guess. Does that make sense?
Not
But,
really.
yeah, you can't. I mean, if I have all the data, if I have all the grades of all the students, the standard deviation is just a number. I can't change that. It is what it is. It's kind of like, can you change your age right now?
No.
No, it's a number. It is what it is. Does that make sense?
Is there like a calculation, or isn't there a specific like calculation to it?
Yeah, but I don't want to scare you.
Okay.
So I'll say it really. So by the way, my rule is if I say it really fast, you're not responsible. Does that sound fair?
Yes.
It's it's a square root of the summation from I equals 1 to n of x minus mu quantity squared over n minus 1. Do you agree that you don't want to hear it?
Wait, but within this course, do we have to know how to calculate standard deviation, or do we just have to know how to apply it to a set of data?
We'll get how to calculate it, and you're going to like the way, I promise. Okay, I promise. But I want to give you the idea first, and then we're going to do calculations. Got it? So we'll get to the how to calculate next. But I want to give you ideas first, and then we'll get into some calculations. Sound fair? Okay, and I promise you, you will not complain on the calculation. Okay, because you're not going to have to use the thing I just said really fast. Got it? Okay, so let me finish typing. Since even one standard deviation below is, so again, 74, maybe I'll write it down, 74 minus 15, which is equal to 59, is not a passing grade. So I'm not satisfied.
So it would be like subtracting.
Right, because below means subtract, right?
Right.
Right,
Okay, that makes sense.
right. 1 foot below you, if you're, I don't know how tall you are, but if you're 5'6", 1 foot below you is 4'6". Does that make sense? I just subtracted one.
Right.
So that's just what below means. Any questions? Any questions on the standard deviation? Okay, notice I'm spending a lot of time on it. There's a reason. It's the most important statistic in this whole class. You have to know this. So please, I'm really glad you guys are asking questions because this is the biggie. Okay. Mean is also really important, but everyone understands average, or most people do. But standard deviation is something that's it's much harder to truly understand. Okay. So ask questions if you don't understand what it talks about. And it talks about kind of relatively how far away the data points are from the mean on average. Okay, there are a whole lot of others which I'm going to get into, but I want to get into with an example. Oops. So this is where I'm going to write the example. And this is something I do often in this class, is I'm going to do a survey question of you all. And the rule is you have to answer. If you don't feel comfortable because it's private or something, first thing, you can answer in the chat box, and that is not being recorded. Second is that if you don't feel comfortable, lie, but lie reasonably. So if I were to ask, how old are you? Do not tell me you're 780 years old, because that's not reasonable. Okay. But if you feel comfortable, don't lie. Does that make sense? So let me do an example. And how about how many units have you, I guess I say how many college units have you already taken in your life? Everyone understand the question? I want you to put it in the chat box. So 63, and again, this is, I'm not gonna say names on the, when I type these in, 59, I'm just typing in a bunch of numbers. So you don't have to worry about, you know, privacy and stuff like that. But if you don't want the classmates to do it, lie, just give me a number. But I do need a bunch of numbers. 16 and 60, wow. That sounds like me. 33, 180, not a biggie. I think I've had over 1,000 or something, scary amount. Yeah, and guessing is fine too. I just need numbers. What came after 180? Just a minute. It goes real fast. 70, 45, 32, 71. Sorry, 71. Comma 90, comma 41. Any others? Okay, I think I'm going to call it. Hopefully you all answered. Again, I can't force you to answer, but if we don't have numbers, then it's really hard to get a good example. So I'm just going to copy this and you'll see why in a bit. So now maybe I'll do it, even though I have it here, I want to do it. I think I'll do it from the syllabus so you know how to get to it. So if you go to syllabus, and there's other ways of getting here. Yeah, I'm not submitting the quiz. And if you go to calculator, I think I put it in here. Thought I had it in here somewhere. If I haven't, I need to put it in. Probably somewhere else. Sorry about that. Okay, I will put it on the syllabus, but it's just not there yet. So this is the calculator we're going to use. In fact, let me do that now so I don't forget. The thing is, I can change the syllabus as we talk. Okay. Grab it. Okay, so now it's on the syllabus. And if I go to calculator, it'll open up this links to calculators. And we're at the beginning of the class. There's a random number generator that we won't use too much, but if you need to, like I said, if you want to do some random sampling, use random number generator. That's why I put it first. But one variable statistics is what I want. So it says type in the values from the data set separated by commas, which I already did. I'm going to click on it. Whoa, I forgot. Let me do it one more time. So I've got it written. I'm going to copy and paste. So there's my numbers separated by commas. Please ask me if you have any questions about how to do this stuff. Okay, is this the population or did I take a sample? What do you think?
Sample?
Yeah, this is a sample, especially if I want to look at, I don't know, LT students that are college students. So I write sample standard deviation. Usually it's going to be sample.
Wait, is this the calculator that we use for the course in place of the like TI-84 or whatever?
Kind of, yes.
Like this specific
So let me
website.
explain. Let me explain. So this is a calculator that will be for exams and quizzes. Okay, obviously today you didn't need a calculator. I hope you agree, right? For the quiz. If you thought you needed a calculator, you were just confused, right? since there was no calculations. But after today, there'll be calculations to do. And this will be in your quizzes and exams. It'll be embedded in. Okay. But for the projects, you're gonna have to use a different one, and I'll show you that one also. Okay. So I hit calculate. Did that look hard, by the way? What do you think?
No,
Okay.
That's more-
I tried to make it easy. Question?
it looks a lot more simpler than when you have to do it on the TI-84. You have to like go to settings, and then you have to go to like all that.
The students have really told me this is a lot easier than the TI-84. And the reason is the TI-84 does more than just statistics. So I have completely focused this calculator on statistics. And I wrote this calculator, by the way. So if you have any suggestions for it, I'll make it happen. And the reason why I think it's really good is that over the last year, my students have made lots of suggestions. And every time they make a suggestion, it gets better. Does that make sense? So if you have a suggestion, I'll make the suggestion happen. I'm a programmer, and you'll notice that as we go. So now we have all kinds of statistics. Notice these are statistics, not parameters, because remember, a statistic means that it comes from a sample, a parameter comes from the population. So hopefully you know what the mean is. What's the common word for mean? Starts with an A.
Average.
Average. Okay. So what we can say is that the average number of units that students have taken is about 72 units. Okay. By the way, just a note, what kind of sampling did I just do? What's the name of the sampling technique I just did?
Convenience sampling.
Convenience.
Totally convenient sampling, which means do not say, you know what, the average of all college students in California is 72, because this was convenient sampling. This has all kinds of bias. Just a warning. Does that make sense? So if I wanted to do a really good study, then I'd probably do a stratified sample, okay, with multiple strata. All right. I hope I don't need to spend much time talking about minimum. You all good with that? That the lowest number of units for the sample was 16. Okay, Q1, something you may not have seen before. Q1 is really important. Q stands for quartile. So let me write this in the chat box. Q1 is the first quartile. And that means that basically 25% of the data is at or below this number, Q1. So we also call it the 25th percentile. Any questions on the idea of Q1? Any questions? Okay.
Still confused as to how you got 37.
All right, so here's the really terrible news. And I'll let you know, it is absolutely terrible misery for me. It won't be for you. And the misery is there is no standard way of computing Q1. The Statistical Association of America has not determined a set formula. Isn't that awful? The good news for you is you don't have to care. Because how did I get it? I got it by doing a whole lot of coding that you never have to worry about. Does it sound fair?
Yeah.
And I used what's called the spreadsheet way of doing it. If you use a calculated way of doing it, you'll actually get a different number. Is that awful? That there isn't an agreed upon way of doing it. So the good news is you don't have to do it. I won't test you on the calculation, but I will test you on understanding what Q1 means. Does that make sense? So if I asked you for an example of the 15th percentile, you need to give me a number that's less than 37, because 37 is the 25th percentile and 15th percentile is lower. Does that make sense?
Yeah, it makes sense now.
Yeah. So I apologize if I don't have a good answer for you. But again, since I programmed this, it was so hard and I get so many, but that's not what I got when I use my calculator. How come yours doesn't agree? And it's like, oh, sorry. Such a pain. So there is no agreed upon number. I wish there was. So just trust me that just go with it. Sound good? But I do want you to get the idea of it. The median is 61. And we've talked about the median already. That means half of students have taken basically less than 61 units and half have taken more-ish. Okay. What do you think Q3 is? Any guesses?
75th.
Yep, that's the 75th. So Q1 is the 25th. Q2, which no one uses Q2, is the median because that's 50th percentile, and the median is the 50th percentile. And Q3 is the 75th percentile. So I'm hoping that's clear. Besides that, we already have it in the chat from someone else. So, so that means Q3, the third quartile, is 80.5. Any questions on that? Maximum, I hope you all understand, 180. That means that the highest number of units is 180 for this group. All right, standard deviation, about 50. So we've talked about it already. Remember, that's one of the key numbers of all statistics. Is that, what do you think? Do you think it's big or little? Right, this isn't like a
standard deviation.
Yeah, you think it's big? Yeah, it's pretty many. 50 units is a lot of units, right? Okay, 50 units is more than a year of full-time student. Does that make sense? So we do have a big standard deviation for this sample for y'all. Okay, which I'm not too surprised because again, if we look at the maximum is 180 and the minimum is 16, that's a giant range of units, isn't it? So we're not surprised that we have a standard deviation. Any questions on that? Okay, the variance, honestly, the variance I put in because an instructor from a different college wanted it. So I put it in for that person. I won't ask you to interpret the variance. The variance doesn't usually, mathematically there's some interpretation, but practically it doesn't have a good interpretation at all. It's not, if units of variance in this case would be units squared, which is silly. So if you ever try to explain what the variance represents, think again. Got it? That includes your projects, by the way. Okay, IQR. Let me write this in the chat box because it's important and it's something you may not have seen before. So IQR is the interquartile range. So IQR is the interquartile range. So IQR is equal to Q3 minus Q1. So it's the range between the first quartile and the third quartile. Another way of saying it is the range of the middle half of the data. Any questions on that, or was that confusing? Okay, and then hopefully you all understand what sample size 12 is. There were 12 of you that answered. Any questions at all on any of these statistics that we got out of this example? Okay, and let me do this just in case you want it. I think I'll do it here. I put the link in the box. If you want, you can pop that link and put it in your favorite, in your bookmarks or something. And that way you can easily get to it. And that is the link. And I built this calculator, by the way. So again, please, if there's anything that you find that could be done better or is confusing, whatever, let me know and I'll address it. I'll make it better. Okay. And again, I've been using it now for over a year. So I've gotten a lot of good comments and I made a lot of good changes already that students asked for. But if you have more, let me know. And I do want to let you know, just in case you're nervous about this, I don't make any money on this. Okay. I give this out for free. So you don't have to say, well, you're, giving advice for free and that's not fair because I get all the money and I don't make any money on this. I'm doing this just to help people. So just let you know, you don't have to, feel like you're getting cheated out of your money because I'm not making money. Okay, it's just an online resource. Okay, and notice, by the way, when you look at this calculator, there's a lot of different choices. So here's the warning. This class has a lot of things in it. And I made a calculator for everything we do in the class. So you're gonna be using all of these. A little scary, huh? Any questions at all? Okay, there's also, I'm not going to do it today, but there's a frequency table that you can also do. If you're given the frequency table, then you put in the midpoints, you put in the frequency, and it'll also give you all the main things you want. For those, mean, standard deviation, 5-point summary. 5-point summary is a minimum, the Q1, the median, Q3, the maximum. That's the 5 numbers that are a 5-point summary. Any questions at all? All right, I think what I want to do, we have that's kind of like a break, but I think it's good to have a 5-minute break since I've been talking a long time. So let's take a little break. It's 5:02 and let's come back at 5:07. I don't need the break. So if you have questions, I can answer them. I might drink some more water. I need to drink a lot of water during talking like this. But I think I'm going to take, I think it's important to have a little break. So we're at break. And maybe I'll even stop the share and pause the recording. Hopefully this will work. And let's get back to what we're doing. Okay, a couple more things. Let me give you one of my favorite examples. And that is, let me give you an example. And that is that on the SAT, nowadays, I think people aren't taking the SAT this year, but I had to take it when I was a student, when I was in high school. And I scored 860 on my SAT. My daughter scored 2020 on her SAT. Who did better?
Your daughter.
Are you sure? One thing you definitely know is my daughter's a lot younger than me, obviously.
Back
Didn't they
in the
change
day,
the
wasn't it out of?
scale?
Wasn't it out of like 2000? It's out of 1600 now, but wasn't it like more?
It was at a 2400, I think.
I know, but when he was taking it, wasn't it worth like, or wasn't it only like 200 or something smaller?
Yeah, even if you knew what it was out of,
that makes sense.
even if I told you what it was out of, you still can't tell who did better because you don't know how everyone else did. So it's really, how did you do compared to everyone else? Okay, so the problem is what I just told you is something you can't answer. You don't know which is a better score because the scores are meaningless without knowing how they are compared to all the other people who took it my year and all the other people who took it her year. Okay, so that the score that I got is meaningless, is worthless, right? Because unless you happen to be exactly my age and you took it my year and you remember, but my guess is that's probably false, then you can't answer that question. Okay, so let me tell you in a different way, and that is the Z-score. And the Z-score, by definition, is Z is equal to the fraction x minus mu, I'll get bigger in a minute, over sigma. So a lot of different letters here. And let me make this big so that you can actually read it. Okay, so that's a z-score. Okay, now here's what that says. So first thing is x is the value you're interested in. So my SAT score was 1,260. And then there's mu. Mu is the mean. First letter of the word mean. And this is a Greek letter. And it's kind of the letter M in Greek. So we use the Greek letter mu. And you are responsible for knowing that that letter is the population mean. Not just any mean, but it's a population mean. Sigma, that's a Greek letter. That's this denominator. That is the population standard deviation. So any questions on what these letters are?
What is sigma? It cut out.
Sigma is the population standard deviation. So just a note, because I've got it below, I wrote all the different letters we're going to be using. Or some of the main letters at least, for this class. So X with a bar on top, and the formal way of saying it is X bar. Easy to remember. That's the sample mean. So if it's data that comes from a sample and you take the average, that's X bar. Mu is the population mean. Okay. My cat is very interested about the population mean. Do you know how I know? Because she's always going, mew, mew. So she must be screaming for the population mean. Sound good? Good way to remember it? So that's how I remember population mean, and that's the mu. S is the sample standard deviation, and sigma is the population standard deviation. And Z is X minus mu over sigma, and what this mathematically represents is how many standard deviations you are above or below the mean. Any questions on this idea? So again, I told you my SAT score, my daughter's SAT score, and that was a meaningless number. Okay. On the other hand, what if I told you my Z-score for my SAT was 2.4 and my daughter's Z-score was 2.2? What do you say? What do you think that would tell you? Any ideas?
By 0.2.
What's that?
You did better by 0.2.
Yeah, so I did better. By 0.2 is a little harder to say that, but I did better. My Z-score was 0.2 higher than hers, right? Okay. The other hand, so I did it better a little bit. What university do you think my daughter went to or got into if her Z-score was 2.2? What university do you think she got into?
Well, we don't know which one she applied to, so we can't answer that.
But which one could she get into?
Depends on the year.
No, it doesn't actually.
It completely does. If the
Only a little bit.
If how good an SAT score is depends on the year, and so does whether or not that score gets you into university.
No, but that's why I'm giving a Z-score. See, the Z-score tells it all. And the idea, a 2.2, means that it's more than 2 standard deviations above the mean. So that means she was an outlier on the high side. Does that make sense? So over 2 is an outlier. Outlier means that you're very high compared to everyone else. Okay, if I told you just her score on her SAT, which was 2020, then then it depends on what year. But if I tell you the z-score, it doesn't, because she got over 2 standard deviations above the mean, which means she's an outlier on the high side of her SAT score. So any guess? And I'll tell you, she went to a public university. Any guess where she went?
Berkeley.
Berkeley. She went to Cal. Okay. And she graduated, by the way, from Cal already. So she's done, which means I don't have to pay anymore. That's always good. But she went to Berkeley. Okay. If you get a z-score of, let's say, 0.5, do you think you can get into Berkeley?
Oh, no.
No, because then you're kind of like very normal, and Berkeley doesn't want the very normal students. Berkeley wants those really high students. Does that make sense?
Yeah.
Okay. Now, if your z-score is negative 1.3, where can you get into?
San Jose State? Probably
not. They actually have some standards.
Any community college?
Yeah, any community college. Okay, it doesn't matter what your z-score is, you can get into a community college. Any California community college. I don't know about other states, but I know our state. So any community college will accept you if your z-score is whatever it is. Doesn't matter. Does that make sense? Yeah. So the z-score is a really good number to give you an idea of how unusual it is. You on the high side or the low side. So let's suppose that that you're a nurse or a doctor, and you are in the delivery room, and the mother just delivered a baby, and the baby's z-score for weight is negative 2.6. What do you think you're going to do if you're a nurse or a doctor in that room?
That the baby is premature?
Yeah, baby's premature, and you're probably going to have to keep that baby in the hospital a while, because when you have a baby that has a very small weight compared to what babies are supposed to have, then that means you need to check up that baby and see what's wrong. Does that make sense? So that would be a really low z-score, and it's a big problem for baby weight, for example, for newborn weight. What if the z-score was 2.5? What does that mean if you're the nurse or doctor?
The baby is relatively more normal?
Definitely not. Definitely not normal. 2.5 is
overweight, yeah.
Super overweight, and you're probably going to have to conduct a C-section because that baby is so big, it's not going to come out very easily. Does that make sense? Okay, and if you're not going to conduct a C-section, boy, is that mother going to be in pain. So those are so z-scores really tell you, even if you don't really know, I don't know what an average baby weight is, and I don't know what a really low baby weight is. I don't need to know. But if I heard the z-score, I understand it. Does that make sense? The z-score is really a nice number when you're trying to understand how unusually big or how unusually small a number is. Any questions on that idea? Oh, the definition of z-score is right here. Z equals x minus mu over sigma. That's the definition of z-score. In words, it's how many standard deviation above the mean the value is. Okay, hopefully that answers your question. So the definition is a formula, but the idea is what's below it. Okay, and if z in absolute value there we go. If the absolute value of z is greater than 2, then it is an outlier. And then I'm going to do this by copy paste. If the absolute value of z is greater than 3, it is an extreme outlier. Okay, so let me put those in red because that's a definition. Any questions on the z-score? Any questions? Okay, makes sense? So all of this stuff is important, by the way. We're going to be talking about it and using most of the stuff for the rest of this course, especially mu and sigma and x bar and s. So these 4 that I put in red, you got to get those down. Okay, then hopefully you understand them now, because I spent a lot of time, but you're going to have to spend a lot of time practicing and understanding. Okay, the next thing I wanted to show you is the other calculator. The other calculator, and that one, I think I've got it linked. If you go into the projects, I think that's where you can find it. If not, I'll put it, make sure I've got it for you, because that's when you're going to need it. And if you click Project Spreadsheet Resources, and you click Google Sheets Statistics Package written by Larry Green. So I created this also. And if you click this right here, then this takes you to the spreadsheet that I created. So I want to mention something. You may say, well, why can't I use one calculator? There is a reason why I'm using the spreadsheet and requiring it. And that is my #1 priority in this class, I've mentioned to you before, is that this class transfers. And there are some universities, some majors, where if I don't use a spreadsheet, if you don't use a spreadsheet in the class, then they're going to make you retake this class. And that sucks, doesn't it? So they're going to call me up. They did use a spreadsheet. I'm going to say yes. And they're going to let you not have to take it when you get to your university. So to me, again, that's #1. And hopefully you agree. That's #1, is that this needs to transfer for you. So I created a spreadsheet program. And for the project 1, you're going to have to use this. Any questions on that? Okay. The first thing you need to do once you open it is you have to go to File, make a copy, give it a name, and hit OK. I'm going to hit cancel because I don't need another copy. But that's what you have to do. Otherwise, you won't be able to do anything. You won't be able to edit, because this is a Google Sheets. And Google Sheets, you're not able to edit unless I give you and the problem is if 2 of you editing at once, then you're going to be fighting each other. So what I do is I don't have any editing privileges. But if you make a copy of it, then it's yours and you have it. Okay, so if you go to project 1, let me start again. So if you go to the syllabus, there's a few ways of getting in, but one way is if you go to the syllabus, if you go to project 1, and then you'll see project spreadsheet resources. Click on that. Then you'll see Google Sheets statistics package. And then you click this one on starting out. Okay, do it. Figure I might as well do that since it'll probably help. Is the following. In a moment, it takes a second. Is click on that link that I just put in the chat box. And now you've got it. Okay, and then you got it and you can make your own copy and then you own it. And the nice thing about this is your project groups can use this as a single Google Sheets and you can share it with each other if you know how to use Google. So I like Google. So anyhow, it's a spreadsheet. It does everything we do in our class, but in particular, it does what you need to do on the projects. And for project 1, you're going to be doing this first tab, the one var stats. So let me ask you, what are you interested in? Let's do another survey. What do you want to find out? It needs to be quantitative. So what's a good survey question you want to hear from each other? First one to put it in, we'll use that one.
Favorite show?
Favorite, I missed it.
Favorite show?
Okay, favorite show is qualitative. Like mine is Star Trek, and that's not a number. So it needs to be a number because we're doing statistics. Can't do statistics like.
How many pairs of shoes we have?
Okay, how many pairs of shoes do you have? So put in the chat box how many pairs of shoes you have. And just guess, you don't have to like, who cares about your exact number? Okay, 28, wow, you have a lot of shoes. 9, 26, 8, 7. 5, 10. 6, 6. 7. Any others? Okay, I'll just call it that. So all I had to do is I typed in the numbers. You don't do anything, it just gives everything to you. So here's the minimum, the mean, the sample variance, the sample standard deviation, the median, the maximum Q3, and we'll get into the SNL left. We have Q1. So it gives us everything. It gives us more stuff we haven't covered yet. But I want to focus on the histogram. So it creates a histogram. And a histogram is a chart at which the x-axis is quantitative. So notice numbers 0 to 6, 6 to 12, 12 to 18, 18 to 24, and 24 to 30. So numbers, never words, numbers. So only for quantitative surveys. And the y-axis is the frequency, or what Google calls the count. And there's our histogram. Okay, this particular one is unimodal. Unimodal means there's one mode or one highest frequency bar. Do you see that? There's one bar that's higher than the others, and that's the way it is. Any questions on the histogram? Okay. So we can also, and this is something that your computer may hate. Yeah, it's a bar graph where the x-axis is numbers. So bar is more general. A histogram is a special kind of bar graph where the x-axis are numbers and the numbers are actually divided equal widths. Whereas if you asked something like, what month were you born in? Then you could draw a bar graph of that, but that wouldn't be a histogram because I was born in July, that's not a number. Does that make sense? So it's a bar graph with quantitative with equal widths. So if I click on stats and I go to stem and leaf, and wait a moment, then this creates what's called the stem and leaf diagram. Okay, and what this does is it has stems and leaves. So the stems here are tens digits and the leaves are ones digits. Any questions so far on that? Okay, notice what we get out of this is we haven't lost any of the data values. If you look at the histogram, in looking at it, if I asked you just from the histogram, how many people had 8 pairs of shoes? You can't tell me. Do you agree? You could say that 7 people had somewhere between 6 and 12, but you don't know how many people had 8. Any questions on that idea? On the other hand, with the stem and leaf, 8 is 0 tens and 8 ones. So there was one person who has 8 pairs of shoes. On the other hand, if I asked you how many people had 7 pairs of shoes? There were 2 people. Notice this number 8. That's 2 10s and 8 1s. Well, that's 28. Any questions on reading this stem and leaf diagram? So stem and leaf diagrams are great if you don't want to lose the data values, if you want to keep all of your data values and show it. Okay, when do you think stem leaf really won't work? Any thoughts?
With larger sets of data?
Yeah, let's suppose you wanted to look at the SAT scores in all of America. Okay, well, how many are there? Probably millions, right? There's no way you could put millions of numbers on a little graph like this. It wouldn't fit. So stem and leaf only works with smaller data sets. The other thing is that if you're presenting to an audience, stem and leaf scares people because they don't know what it is. People who are number phobes, which means they hate numbers, would hate this. They're all going to run out of the room. Whereas a histogram is a little friendlier.
Wait, so can you do a stem and leaf plot with 3-digit numbers, or is it only possible?
So let me show you
how
I did it and how I programmed it. So that's a good question. So I'm going to make up, I'm going to change. Let me do the last chart and then I'll talk about it. Sound good? So I can change, so I don't have to change the numbers yet. So if I go to box plot, it's going to give me a picture of the 5-point summary. So the box plot gives a picture of the minimum, the first quartile, the median, the third quartile, and the maximum. So notice the box in red goes from 6 to 8.25. So we could say the middle 50% have somewhere between 6 and 8.25 pairs of shoes. Any questions on that? We could say the range is between 5 and 28 because we know the minimum and the maximum. The median was 6. Oh, sorry, median is 7. The box plot is a nice pictorial way of representing those 5 numbers. Box plots are horrible for general audiences that have never taken a statistics class because they don't even know what it is. Does that make sense? Okay, now it turns out every 18-year-old has seen a box plot. Anyone know why? At least in California.
Is it on some standardized test?
Yeah, you're close, actually. You're very close. Have you heard of the Common Core standards?
Oh, yeah.
So the Common Core standards now include box plots. Whereas when I was a kid,
I don't remember that.
Okay, so that means you don't remember because maybe you were in 8th grade. It might have happened in 8th grade. Or it means your teacher didn't do what your teacher was supposed to do. That's possible too. So there's, at least they're all supposed to have gotten box plots because now it's part of the Common Core. So just let you know, I was like one of the Common Core experts because I was both on the school board and I was a math teacher. So everyone went to me about Math's Common Core. So you can trust me on this one. It is part of the Common Core. There's a lot more statistics in the Common Core than there used to be. And box plot is one of them. That doesn't mean your teacher taught you it. They were just supposed to. Sound good? So if any of you are going to go into teaching and you're going to teach middle school math, you need to understand example because you're going to be teaching it. Either middle school or high school. Okay, so anyhow, older people have never seen a box plot. Okay, unless you're like me, you're a math major. So any questions on the box plot? Okay, notice you can definitely see that above the third quartile is this big long spread. That means 28 is probably an outlier. Any questions at all on the box plot? Okay, the next question is, what about if it was, you wanted 3 digits instead of 2 digits? Let me show you how to do that with my program. Every program's a little different, but the one I have, the one I created is this. So I'm gonna kill the box plot. let's put in some 3-digit numbers. I'm just going to randomly grab some. Just easy numbers to type in. That's probably enough. Okay, so if we want to do 3-digit numbers, that means we're going to want the stems to be hundreds digits. So see where it says S and L left 10 power? So if it's 10 to the first, that's 10. If I want 100, what 10 to what power is 100?
Second.
Second. So I'm going to change that to a 2. Hit enter. Now if I go to stats and I go to stem and leaf, notice now it gives you hundreds and tens. Any questions on that? Okay. And I'm going to change something just for showing you something different. I'm going to change that 876 to how about 666. And there's a reason I'm doing this in a moment. So let's go back to the box plot. Oh, sorry, I don't want box plot. I want stem and leaf again. Much better. All right, so this one, you'll notice it's unimodal. Do you see that? The mode is in the 30s. And notice from the mode, it goes down to the left. It goes down to the right. So if you have a graph that starts low, comes up high, and then comes back low, then we say that is approximately normal. Can you remember that word normal? So that shape is a normal shape. Where have you seen a normal shape before?
Bell curves.
Yeah, bell curve. Okay, because that's another math way of saying something. How about in the world, in nature, for example? You ever play at the beach? You ever drop sand down? What shape does it land in? It lands in this shape. Okay. And that can actually be proven with some hardcore physics, which I'm not going to do, but you've all seen it. And it's called a bell curve. It's a normal distribution. It's kind of the shape of like little sand piles. Okay. There are lots and lots and lots of things that have this shape. And I'm going to let you know it is the most important shape in class. It's so important that we actually have an entire chapter devoted to it. So we're going to spend a whole week just on this shape. We're not ready for all the details yet, but right now I just want you to get used to this is that shape. Any questions on that? Okay, on the other hand, let's change it a bit. I'm going to throw some more numbers in just for fun. And let's do another stem and leaf. And hopefully I did what I wanted to do. Is that one normal?
No.
No. Okay, is it unimodal? What do you think? Is this one unimodal? What does uni mean, like unicycle?
Many?
Not money. Unicycles aren't about money.
One.
One.
Okay.
Yeah, right. A unicycle is one wheel. Okay. So mode is kind of the high bar, remember? This has one high bar. Do you see that? right? And that is this one, this first bar right here, the 100s bar. So this one is unimodal, but it's not normal. What this one is skewed right. So let me write unimodal, skewed right. Okay, so unimodal means it has one mode or one high bar. Skewed right means that from that high bar to the right, if you kind of move this so that the this vertical line is the x-axis, or you looked at it as a histogram. In fact, we can look at the histogram. Where is our histogram? There we go. So notice that from the high mode, it goes down. And that's skewed right, because the skew, or the going down, is going to the right from the mode. Okay, my guess is you can probably guess what skewed left would mean. Any guess? Yeah, it's the opposite. So it's a mirror reflection of skewed right. What do you think bimodal would be?
Has two modes.
Yep, has two
Two
modes.
high bars.
Any guess on what might be bimodal in the real world? Guess on something that could be bimodal? Any thoughts? All right, if you can't guess, maybe I'll tell you. How about the height of adults? Why might that be bimodal? The hint, there's a mode around 5'10", and there's a mode around 5'4". Any guess on why it's bimodal?
Genetics.
Yeah, that's something very special in genetics that you all know. And you've known since you were little. All right, don't see y'all jumping in. Men and women. Average male height is 5'10". Average female height is around 5'4". So you're going to see a mode around 5'10" and a mode around 5'4". Does that make sense? So if you look at, heights of humans, that'll be bimodal. Any questions on that? So bimodal usually comes from when there's two types, like men and women or something like that. Any questions at all on the charts? Any questions? Okay, so there's a lot of statistics that we have talked about, and you're responsible for all of it. And you're going to learn that there's a lot in this class. So don't shoot the messenger. It's not like I made up a bunch of extra stuff for you to learn that no one else learns in any other college. I just go through all the content that pretty much every class does in stats. So hopefully you all understand all the main things. In terms of the main points, I always like to do a summary if I can, especially if I got time. What are the main statistics that you really are responsible for having a very strong feel for? Standard deviation, z-score, and mean. Okay, so I'm going to say standard deviation and mean are the two biggies. Z-score is an important one, but it's not the main. So standard deviation and mean, those are the two biggies, and you need to fully understand those. We're going to be using them over and over and over again in this class. Okay, so I thought just for fun, let's see how you do. Since I created a game, maybe we'll play it. We got a few minutes. Let me go back to the book. And the Zoom, I got to move things around. Sorry. There we go. Chapter 2. think it's in this one. Okay, so this is the guess the standard deviation game. Let's see how I do it in the game. Okay, so I'm going to click next. And I want you to see if you can guess what the standard deviation is. And again, it's not exactly 1, 2, or 3, or 4, but see if you can get the number that it's closest to. You can put in the chat box. So here's a histogram, by the way. And let's see if you can guess what the standard deviation might be for this histogram by looking at the values and the numbers and the bars. And if you put in the chat box, then we'll make the guess. So let's see if you can guess what the standard deviation of this histogram might be. And the goal of this is to give you a feel for standard deviation and histograms. Okay, shall we try 4? Okay, a couple of people say, let's try 4. Perfect. So again, the two of you definitely understand why it's 4, at least unless you guessed, but I'm guessing that you understood it. But let me explain it for everyone. So notice that the mean is somewhere around here, around 4. The standard deviation is the average distance from the mean. So notice that if the standard deviation were 1, that means that the average distance of the bars is only 1 away from 4. Well, between 3 and 5 does not cover much. Almost nothing is in that area. Notice that if you go 4 away from 4, you get to 8. That's the tallest bar. And 4 to the left is 0, and that's also the tallest bar. So you see that we have a lot of stuff that's 4 away from 4. We do have 9 of them that are 5 away from 4. And then we have some that are less than that away from 4. That kind of averages out to about 4 away from 4. Any questions on that? Let's try another one. Okay, what is it? What do you think this one is? Okay, should we try 3? Close, it's 4 again. So here's your, it looks like 4 around here is somewhere around the mean, somewhere around here. And notice that like there's a big bar here at 9. It's really far away from 4. There's also big bars at 0 and 1. And that's really far away. So 4 was the answer. We were close. Let's try one more. What do you think the standard deviation is for this one? Okay, should we try 1? 1, 3, let's see what we got. Okay, so let's take a look at this before I guess. Notice that the mean is somewhere around here. If I go 3 to the left of the mean, there's nothing farther than that. And if I go 3 to the right of the mean, there's nothing farther than that. So the average distance from the mean can't be 3. Is that clear? So it's going to be 1 or 2. I could type 1, but it's actually 2. Because notice that over here, if we go 2 away from the mean, that kind of gets to, there's some to the left, some to the right on both sides. So the answer is 2 on that one. I recommend trying this until you get good at it and you'll get a good feel, just kind of a in your heart feel for the standard deviation. Any questions on this little game I created? Okay, and this is in the book. You can find it by going to the textbook, and then it's chapter 2 because that's what we're in. And this is 2.8, okay, which is measure of the spread of the data because standard deviation is a part of the spread. So it is 5:50, so we're done. Let me stop the share and let me stop the recording.